Hello everyone, welcome to Physics Fantasy. If you are getting benefited from my video, then please do like, share and subscribe. आज की वीडियो में हम डिस्कस करेंगे प्रीवियस ईयर क्वेश्चन ऑफ जेस्ट एग्जाम which is basically based on harmonic oscillator in quantum mechanics. Let's do some problems on harmonic oscillators. This is the first question. Consider a system of 15 non-interacting particles, non-interacting spin polarized electrons. They are trapped in a two-dimensional isotropic harmonic oscillator of potential half m omega square x square plus y square. The angular frequency is omega and the value of h cut omega equal to 1. What is the ground state energy of the system? To do this problem, we have to understand some basic concept regarding the question. Non-interacting spin polarized electrons means they are oriented in a particular direction with particular spin, okay? And isotropic harmonic oscillator. What do we mean by isotropic harmonic oscillator? If it is written as isotropic, you will find that it has only one frequency. That is, there is no change in angular frequency in different direction. If it is written as anisotropic, then you will find different types of angular frequency with respect to different directions like omega x, omega y and omega z. And another one is, this is the potential v of x equal to half m omega x square plus y square. This shows that it is a two-dimensional harmonic oscillator. To find out the ground state energy, we have to find how electrons are arranged in the ground state. कैसे इलेक्ट्रॉन्स अरेंज हैं ग्राउंड स्टेट, उसे फाइंड करने के लिए हमें पहले पता लगाना होगा कि इसका डीजेनरेसी क्या है. For two-dimensional harmonic oscillator, the ground state, the degeneracy will be G will be n plus 1, where n is the states. And for three-dimensional, it is 1 by 2 n plus 1 into n plus 2. But here it is given as it is a two-dimensional. So here degeneracy will be n plus 1. Okay. Now we can arrange the 15 electrons in the ground state. If we arrange the 15 electrons in the ground state, then we will find that 1 into h cut omega plus 2 into 2h cut omega plus 3 into 3h cut omega plus 4 into 4h cut omega plus 5 into 5h cut omega. And if we solve it, you will get 55 h cut omega, and you know h cut omega equal to 1, so answer will be 55. Now come to the next question. A one-dimensional harmonic oscillator in the state psi is given Here n is a normalized eigenstate, energy eigenstate with energy eigenvalue n plus half ℏ omega. Let the expectation value of the Hamiltonian in the state psi can be expressed as half alpha ℏ omega. Then what is the value of alpha? Okay. Now it is given, psi is given, and we have to find out the expectation value of h. Okay. For expectation value of h, we know that it is psi cap psi, and it is given all where psi is summation over n equal to 0 to infinity 1 by square root of n factorial and ket of n. If we trying to solve it, we will get summation over n equal to 0 to infinity 1 by n factorial square of n plus half ℏ omega, which is Hamiltonian, and then after this we will get summation over n equal to 0 to infinity 1 by square root of n square. It will be only n factorial. By squaring it, we will have only n factorial and n plus half ℏ omega, and where this will be equal to 1. As we know, n is a normalized eigenstate, so this will be equal to 1, and we will only have a summation over n equal to 0 to infinity n plus half divided by n factorial into ℏ omega. And if we solve it, we will get equal to 1 by 2 ℏ omega plus ℏ omega summation over n equal to 1 to infinity n by n factorial. Okay. First, if we put n equal to 0, it will come out to be 1 by 2 ℏ omega plus ℏ omega n equal to 1 to infinity n by n factorial. Okay. And if we solve it, you will get 1 by 2 ℏ omega plus ℏ omega. If we try to solve it, 1 plus 2 by 2 factorial plus 3 by 3 factorial, and then 1 by 2 ℏ omega plus ℏ omega into 1 plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial. If we don't know, this is only e. Okay, if we find out, this is ℏ omega into 1 by 2 plus e. If we equivalent with 1 by 2 alpha ℏ omega, then we will get alpha is equal to 6.4. Now it is another question. A quantum particle of mass m is in one-dimensional potential of the form v of x half m omega square x square when x is greater than 0 and is infinity when x is less than 0, where omega is a constant and which one of the represent possible ground state wave function. Okay, as we seen from the potential, that is हाफ एम ओमेगा स्क्वायर एक्स स्क्वायर, ये बोलता है कि ये जो पोटेंशियल है हार्मोनिक ऑसिलेटर का है. तो दिस इज ए पोटेंशियल ऑफ हार्मोनिक ऑसिलेटर. एंड वी नो दैट, हम जानते हैं कि जो हार्मोनिक ऑसिलेटर का वेव फंक्शन है वो क्या है, एक गॉसियन वेव फंक्शन, which is a Gaussian wave function. Let us find out which one of the following is correct. Now for ground state, how we will find which of the following is the graph of ground state wave function. From the graph we can know this by the nodes. Know what is nodes? Nodes is the zero crossings. The zero crossings. For ground state there should be no zero crossing, so C and D will be cancelled as they have many zero crossings. But in A B there is no zero crossing. But पर ये जो ए का जो ऑप्शन है ये एक गॉसियन वेव फंक्शन नहीं है, तो आंसर शुड बी बी. And another one,